Use Newton's method to estimate the two zeros of the function f of x equal x to the fourth plus x minus 3, and start with x sub 1 equal negative 1 for the left hand zero and x sub 1 equal 1 for the zero on the right, and we're supposed to work till we find x sub 3. So first we're going to start by looking down here at the graph for reference. We're going to be after that and approximate for that zero. We found that if we want a little better approximate for x, we're going to start with the x in front, subtract the function value at that x, divided by the derivative at that x. So this was our formula we came up with for Newton's method. So we're going to need the derivative of this function. That's going to be 4x to the third plus 1. Now let's go ahead and write up the steps for obtaining x sub 2. So we're going to start with x sub 1, which is negative 1, minus the function at negative 1, divided by the derivative at negative 1. And that looks like that is 1 minus 1, so negative 3 over negative 4 plus 1, negative 3 over negative 3. That's 1, so negative 1 minus 1 looks like that ends up giving us a negative 2. So now to find x sub 3, we use the negative 2. Oh, before we finish here, let's go back and look at our graph here and see what we just did. We started here at 1, we went down and we found the function value, and then we followed the tangent to the curve and it went right up here, and its x-intercept was negative 2. That's not a very straight line here, but you get the idea. Alright, so we're going to use that negative 2 minus the function at negative 2 divided by the derivative at negative 2. And so we can go ahead and figure that one out, and it looks like this one gives us negative, let's see, I'll put it right here, negative 1.64. We're going to carry it out about 5 places here, 516. Now this told us to only go to x sub 3, so we're done. If we were trying to get a certain accuracy, we would carry it out that many decimal places and then continue the method until we saw that it didn't change in that decimal place that we were desiring the accuracy for. Alright, let's go ahead and do the other one. And actually, looking at our graph, negative 1.6 something looks about right for this root. Alright, let's start now with finding x sub 2 for the other one when we start with a value of 1. So 1 minus the function at 1 divided by the derivative at 1. And that's going to be 1 plus, it looks like 1/5, so 6/5 or 1.2. Now let's find x sub 3, and x sub 3 is going to be 1.2 minus 1.2 to the fourth plus 1.2 minus 3, the function at 1.2, divided by the derivative at 1.2. And when we put that one in, we get 1.1654, and then we'll round that to a 2. Now that looks reasonable as well for this root over here.